algebra and composition with functions. So when you have two or more functions, you can add the functions, subtract them, find the product between two functions, and also form the quotient or division between two functions. So for now, they have 1, 2, 3, and 4 operations between functions. Let us go over an example to see what's going on here. So suppose you have a linear function, 4x minus 3. Second function is a quadratic function, 4x squared minus 7x plus 3. The third function, again, a linear function. Question says, hey, find the addition between f and g, find the product between f and h, find the product between f and g, and finally find the quotient of g and f. To add two functions, we take the definitions of those functions and add them together. So f of x plus g of x. F of x is 4x minus 3. G of x is 4x squared minus 7x plus 3. We have to simplify this sum. We're looking for like terms, similar terms, which are 4x minus 7x. If you add these together, the outcome is negative 3x. You have minus 3 plus 3, which is 0. You also have 4x squared, the only quadratic term. So you copy down the quadratic term, 4x squared, and the sum of 4x minus 7x is negative 3x. So 4x and minus 7x are like terms because they have the same degree. Both of them are on degree 1. So 4x minus 7x is equal to 4 minus 7 times x, which is negative 3x. So this is the sum of these two functions. So we're done with the sum. Let us find the product between f and h. We take the definition of f, we take the definition of h, and we multiply them together. So f is defined as 4x minus 3 times, don't forget to use parentheses, h of x, which has two terms, x minus 1. Very well. Here you have 4x minus 3 times x minus 1. You can use distribution or FOIL method. 4x times x is 4x squared. 4x times negative 1, negative 4x, minus 3 times x, minus 3x, and minus 3 times minus 1 plus 3. As you can see, you have like terms, negative 4x minus 3x, which is negative 7x. we copy down the first term, 4x squared minus 7x plus the constant 3. 4x squared minus 7x plus 3, which in this special case is equal to g of x. Let us multiply f and g. F is 4x minus 3, so we copy down the definition of f, times g, we copy down the definition of g. Very well, so let us write it here. We can use distribution, 4x minus 3 times 4x squared minus 7x plus 3. 4x times 4x squared, 16x cubed. 4x times negative 7x minus 28x squared. 4x times 3, 12x. Now we distribute negative 3. Negative 3 times 4x squared is negative 12x squared. Negative 3 times negative 7x gives you plus 21x. Negative 3 times positive 3 gives you negative 9. Now we're looking for like terms. The very first term has degree 3, and this is the only term with degree 3. So you copy down 16x cubed. Negative 28x squared and negative 12x squared are like terms. So minus 28 minus 12, you add these two numbers together and put a negative sign in front of it, which is negative 40x squared. Then you have 12x and 21x. These two are like terms. 12 plus 21 is 33, and you have variable x. And finally, you have just one constant, minus 9. So the product of f and g is an expression of degree 3. Finally, finding the quotient between g and f. G over f, you take the definition of g, you take the definition of f, you write g on the numerator, you write f on the denominator, and for now, since you can factor out the numerator, 4x squared minus 7x plus 3, try to factor it out. Maybe you can find common factors between the numerator and the denominator, so you can simplify this quotient. 4x squared minus 7x plus 3 can be factored into 4x minus 3 times x minus 1. As you can see, 4x minus 3, 4x minus 3, these two are common factor between the numerator and the denominator, so you can cancel them out. The outcome is x minus 1. Again, in this example, it happened to have h of x as the outcome of the division between g and f. But note that it's not always the case. Modeling profit, revenue, and cost. Very well. Profit function is defined as revenue minus cost. Profit, P of x, is equal to revenue, R of x, minus the cost, C of x. So how do we calculate the revenue? Revenue is the number of items sold times the price of each item. So you can Formulate revenue function as X times P. X is the number of items sold, and P is the price of each item. The product between them gives you the revenue. Example: a manufacturer of hardshell cases for the iPhone knows that the number of cases she can sell each week is related to the price of the cases by equation X equals to 1,300 minus 100 times P. So X is the number of cases and P is the price. Question says, what price should she charge for each case if she wants the weekly revenue to be $4,000? Perfect. So we know that the revenue follows the following formula, X times P. In this example, X is given. X is a linear function of P. So for X, you substitute 1,300 minus 100 times P in parentheses times variable P. Revenue is equal to X times P. X is given in the question, and P is just a variable that you copy it down here. So we have a nice function. R of P is equal to 1,300. If you distribute P into parentheses, P minus 100 P squared. This is your revenue function depending on P or the price. So question says, what would P be so the revenue is $4,000? $4,000 is the revenue. We know that we want the revenue to be 4,000. We want that money. We set it equal to the right-hand side of the equation, which is 1,300P minus 100 P squared. We can subtract 1,300P from both sides and add 100 P squared to both sides. So we subtract 1,300P and we add 100 P squared to both sides to form a quadratic equation. Now you have 100 P squared minus 1,300P plus 4,000 equal to 0, which is a quadratic equation. Your goal is to find price or P. First of all, divide everything by 100 because each of these terms have factor 100. So 100 P squared divided by 100 minus 1,300 P divided by 100 plus 4,000 divided by 100 equals to 0 over 100. You have to divide left-hand side and right-hand side. You can cancel out 100 and 100. It gives you P squared minus, you can cancel out 2 zeros, 13P plus, and cancel out 2 zeros, 2 zeros, 40 equals to 0 divided by any number is 0. So we simplified the first equation, so we have a nicer equation to solve. We're looking for two numbers, their product is 40 and their sum is negative 13. By inspection, those two numbers are negative 5 and negative 8. We set left-hand side equal to 0 and we solve each of them. P minus 5 is equal to 0. It means that P can be 5. P minus 8 is equal to 0. It means that P can be 8. And finally, let us talk about composition of two functions. The last operation to form a new function. It's denoted by f of g evaluated at x, which is just the substitution of g into f. Substitution. What do I mean by that? Let us take a look at this example. Let f of x be equals to x minus 1. I say evaluate the function when x is equal to a. Or I say, hey, what is f of a? It means that wherever you see x, you just write a. You substitute a minus 1. What if I ask you to find f of b? Wherever you see x, we just plug in b. What if I ask you to find f of x squared? It means that wherever you see x, you just write x squared. Here you have x, instead of x, you write x squared minus 1. So here I say, suppose this x squared is a new function g of x. This is f composed with g of x. Just substitute g into f. This is defined as the composition of two functions. Another example for you. Let f be x plus 5 and g be x squared minus 2x. Question says, find f of g of x, also find g of f of x. F of g of x is the composition of f and g. It means that we substitute gx into f. It means that you take g, which is x squared minus 2x, and you substitute it for x here. Your function f is defined as x plus 5. So f of g is g plus 5. But what is g? G is nothing but x squared minus 2x. You get x squared minus 2x plus 5. We don't have any like terms, so we just write these expressions here. What about g of f? G of f, it means that you substitute f into G. Substitute F into G. So function G is defined as x squared minus 2x. So G of f is f of x squared minus 2 times f of x. Okay, but what is f of x? F of x is x plus 5. So you have x plus 5 squared minus 2 times f of x. X plus 5 squared is x plus 5 times x plus 5. Using FOIL method or distribution, we get x squared plus 5x plus 5x plus 25, which is x squared plus 10x plus 25. Then you have -2 in front of parentheses x plus 5, so we distribute -2, -2x minus 10. We're looking for like terms, 10x, and -2x, 8x. 25 minus 10, 15, and x squared is the only quadratic term. You leave it as it is. So the composition of G and F is x squared plus 8x plus 15. Please note that f of G and G of F are two different functions. In general, f of G is not equal to G of F.